Hello everyone. So welcome back. So in our previous lecture we have studied about work, and in today's lecture we will study about energy and power, and also we will do some sums related to work, energy and power. So first, today's topic, that is energy. Okay. So we understood the concept of work in our previous class, and we also understood what are the three cases when work can be positive, negative or zero, and the units of work in SI and CGS unit and their relation between them. Yes, today's class will be in English. Hindi version of this video I will upload in the next lecture. Okay. So energy. Okay. So what is energy? Energy is basically the capacity to do work. We sometimes say that uh, I don't have any energy to do anything today. Right. So energy is basically it's a measurement. It says that how much work you can do. It's the capacity to do work. This is basically the definition of energy. Okay. So more the energy you're having, you can do more amount of work. Okay. So if I talk about the definition, then we will say that energy is what? It is the energy of a body. The energy of a body is its capacity its capacity to do work. Okay. So basically energy and work as a physical quantity, we can say that the dimension and the SI and CGS unit will be same. Okay. So energy and work, they both have the same units and dimensions. Okay. So the SI unit of energy, SI unit of energy is joule, and CGS unit is what? Erg. And we know what is the relation? 1 joule equals to 10 to the power 7 erg. Okay. But we use some bigger units for energy. We introduce two units, that is watt hour, and another unit is kilowatt hour. Now this concept I am keeping hold for a minute, because first if I give you a brief idea about what is power, it will be easy to tell me what is watt, because watt is the unit of power. So first we will get the concept what is power. Power is basically the rate of doing work. Power is the rate of doing work. This is called the power. In any sentence, if we are saying that there is a term like rate of or by the rate, that means divided by time. Power means we are doing this much work in what interval of time. That gives us the measure of power. So basically power mathematical statement is work divided by time. So its unit will be joule, time is second in SI unit, and in CGS unit it will be erg by time, which is second. Okay. So this joule per second is called as watt. This joule per second is defined as watt. So now here I will come back again. Since we know that power is work per time, power can also be written as energy rate, energy divided by time. This is also we can say power. That means energy I can say is power into time, right? So if power I am expressing in SI units, I can write watt, and time if I say I am expressing it in hour, then I can write the unit of energy can be as watt hour. So this is energy's bigger unit is watt hour. So 1 watt hour why I'm calling this as bigger unit, I will give you an explanation. See, 1 watt, what I already told is joule per second, and hour is what? 60 minute into 60 second. So you see this second, this is in the denominator part, this second, this is in the denominator part, and this is in the numerator part. So this both will get cancelled out, and we will get the ultimate unit as joule, and this is 3600 joule, right? So this means 3.6 kilojoule, right? So this is a bigger unit of energy. And kilowatt hour, kilo means what? 10 to the power 3 watt. 1 kilo means 10 to the power 3 watt. So watt is again joule per second, and hour is 3600 second. This second and this second will cancel out, and we will get the unit as joule, which is the unit of energy. And we will get 10 to the power 3, and here two zeros are there, so 10 to the power 5. 36 into 10 to the power 5, or better 3.6 into 10 to the power 6 joule. So these are the bigger units, and this 10 to the power 6 is called mega. So 3.6 megajoule. There are two relationships, so you know this. 10 to the power 6 is equals to mega. Okay, 10 to the power 6 can be written as what? It can be said as mega. Like kilo is what? 10 to the power 3, right? So these are the bigger units of energy. When we will do sums, then it can be asked that expressed in terms of kilojoule or expressed in terms of megajoule. Then you have to use this type of relations. Okay. Now this next our concept was power. So we understood the mathematical statement, that is work by time. So we also know that work. We also know that work is equals to what? Force into displacement. In the previous lecture I told that work is force into displacement in the direction in which force is applied. So power is equals to what? Work by time, rate of doing work. So force into displacement by time. Displacement by time is nothing but velocity. This also I have explained in detail in my previous lectures, like I think 4 to 5 lectures back. So force into velocity. So we got another expression, power equals to force into velocity. Power is equals to force into velocity, one expression. Energy by time, power, and power is equals to work by time, another expression. Okay, these are the units which is important, and this is the definition which is important. Energy's definition, power's definition, this is important. And the SI unit is what? This is important. Okay. CGS unit is what? CGS unit is nothing but erg per second. Okay, this is important. So note the important thing in a separate copy. Make a small thin copy just for mathematical formulas and units. And this, the point which I have highlighted in the box, you write those terms or those figures in that copy, and the whole lecture you write in a fresh copy. That is a note copy, and that is the formula copy. Okay, so make two copies, one note copy and another is the formula copy. So this is another expression is what? Power is equals to force into velocity. So this was all about my work, energy and power. Okay, we will also discuss one another thing, that is another unit which is a very common unit which is related to power, that is horsepower. Horsepower. It is a unit of power. Okay, and this unit is very much used in mechanical engineering. This is used in mechanical engineering. Okay, mechanical engineering. Now what is the relation? 1 horsepower, it is abbreviated as HP, both are in capital, 746 watt. Okay, so 1 horsepower is equals to 746 watt. So this is also very important. In question they will ask you that express power in terms of horsepower, then you will use this relation. Okay, now we will do some sums related to it. Today we will not do sums, we will do sums in the next lecture. Today one more thing which I will tell you is the difference between work and power. Difference. Let's complete the theory portion today. The next lecture we will do the sums. Difference between, this means between, okay, work and power. See, work is what and what is power? First thing which you can say, that the definition you can write definition. Okay, what is power? It is the rate of doing work, and work is what? It is the force which is equals to the work is basically the product of force and the displacement in the direction of the force. So one point of difference you can say about the definition. Second, SI unit you can say of work is joule, and SI unit of power is what? Watt. CGS also unit also you can say. Third is what? Work is independent of time. Work is independent of time, and power depends on time. Power depends on time. So this is the difference between work and power. Okay. So today we will end our class here. Next class we will do lot of sums, and I will give you some homework. Okay. Thank you so much. Keep studying. If you have any problem, please let me know. Thank you.